so we are back. I have got a new video. This will be showcasing the 4th revision of the wireless power rig. This rig will be comprised of, I think, 8 solar cells with a much more powerful laser. I'll show you that in a minute, but now I need to change something. I think that's better. We have new recording software and a microphone, so hopefully the viewing experience is a little more better. Just a little better. So yeah, this is the new recording setup. Hope it's better. If it's not that big a deal. Right, so now on to the design. Right, okay. So this is the design. This is the 4th revision design, and this is the absolutely massive receiver unit, which has 8 solar cells all connected in series through the back, connected to the 1st generation or 1st revision output terminal. There was no need to change this as it was working the first time, and it has both voltmeter and ammeter outputs. And then if I want to just do voltmeter as I think I've said in the first few videos, I can just put a jumper wire over here to bridge that gap to have all the voltage coming out at this terminal here. As for the transmitter unit, we have a massive 5.5 watt laser diode with its own MCU or master control unit. Now this one laser diode has over double the output power of the smaller laser diodes that I was using before. It has its own cooling system and everything. It even came with its own safety glasses, and if that doesn't tell you how powerful it is, I don't know what will. So with the insane power coming from this, coupled with the amount of solar cells, we should at least get, at the very least, more output power. Which works well because the more photons we have hitting these solar cells, the more light energy we get converted into electricity, and as it's connected in series, all that electrical energy will get added together and chucked out of these output terminals here. And the more voltage we have going out, the more current we'll have going out also, which hopefully should result in me being able to hook it up to a boost converter to then power anything, because that is the reason I am trying to get the voltage and current up, because the minimum required current for most boost converters is in the milliamp range, which is what I'm trying to achieve, because currently we are in the microamp range, but voltage wise we've got it sorted. So if we can boost it down and then boost it up with a model that can actually draw enough current to power the boost converter, we should have a feasible wireless power model. But until then, I will just show you this bad boy in action. Right, so just to give you a little bit of perspective of how powerful this laser diode is, I'm just going to do a trial run now. No voltmeters or ammeters are connected. This is purely just to show how much light this tiny thing emits. And also, I'm just going to show you, it just sounds like a fucking airplane. Right, listen to this. And it gets progressively more loud as it boots up, but if we just power it on now. So that is base brightness. Now it's almost covering the whole thing. But when I use this little concave lens, watch what happens. And obviously the further out I go, the more light actually emits from it. There we go. So yeah, that's how much power we're working with here. Right, so this is the basic ambient room light setting up. I managed to fix the current issue by swapping them around, because I referred to some old test videos that I did a few months ago with the same rig. So now this is the output voltage and this is the output current. This is in microamps and this is in regular volts. So I will now initialize the laser. Okay. So this is sitting at roughly 55 to 60% of the entire array covered, and we are sitting at a comfortable 41.9 volts output and a 56 microamp output. That looks good. I will now add the concave lens to fully cover the array in laser light. There we go. Array is now 100% covered in laser light. There we go. This is now the opposite way around. Looking good. Okay. Now it's time to review the footage, but everything looks like it's balancing out nicely. Right, so I have reviewed the footage, And if we compare the fourth revision's values to the first revision's values, we have a significant increase, because this fourth revision just had a peak of 47.1 volts output along with 63 microamps of current output, which is amazing compared to the first revisions, which had an output voltage of 5.05 volts and an output current of 5 microamps. This is leaps and bounds ahead of the first revision, but it's still nowhere near enough the final value I need in order to successfully connect it to a boost converter, or well, what I actually need to do is I need to connect it to a step down converter to then boost it back up, because the step down increases current, and then with a high enough current you can boost up the voltage to have enough current to power literally anything. So, well, not anything, but enough. So I mentioned old test videos off the cuff. I'll put them up here. They were literally just the same as that, but it was just, there was no video attached to it. It was just basic raw footage, and I thought they were off when I looked at them, and upon revisiting them I found the solution that I mentioned earlier, and I also saw that the values were accurate, which leads me to believe that I might have multimeters that are off and broken, because if you look behind me, you can't see it obviously, but I'll show you. So this is the battery. The battery is gubbed because I had to rip it out of this, so this multimeter is now broken. Along with this multimeter, which is really old, I now have I have two multimeters, but it's effectively half of a multimeter because one of them's really old and one of them's broken. So I think for the next video, the fourth episode of this series, I will have to get new multimeters. I'll probably get two really good ones just to ensure that I'm getting accurate readings, as well as, if we assume we're getting 50 volts out of 8 solar cells, then to get up to 1 milliamp, going by this logic, we will need
1 eternity later.
Roughly 160 solar cells connected in series to produce over 1000 microamps to 1 milliamp, or over 1000 volts of output electricity just to get 1 milliamp of output current. I refuse to believe that is the only way to do it. I know there will be more efficient ways, I just need to find out how to do it, whether that's more powerful lasers or more efficient ways to capture light and transform it into electricity. So I'll leave you on that thought. Really happy with the progress, and I'll see you in the next video.